Bismillahirrahmanirrahim. Hello, my dear students. How are you? I hope you are fine and enjoy your time and good health. Inshallah, we will soon talking about mathematics of finance with compound interest and annuity due. Exercise number 1. What's the future value of $1,000 and annual annuity due for 5 years in a bank that pays 7% converted annually? In this example, we have R equal $1,000. The annuity paid at the beginning of each period. We have 5 years. The total time equal 5 years. And the number of annuities equal 5. J equal 7%. And M equal 1. So I will be equal 7 over 1, which is equal 7%. We were substituting for R equal 1000, for T equal 5 years, for J equal 7%, M equal 1, I equal 7%, so N equal 5. In a formula of annuity due, where is S sub N double dot equal R times 1 plus I to the power N minus 1 over I times 1 plus I. Again, S double dot N equal R times 1 plus I to the power of N minus 1 over I times 1 plus I. Where is R equal 1000 and I equal 7% and N equal 5, so the future value will be equal 6,153.29. Another exercise. Exercise number 2. An annuity due of $750 each 6 months for 5 years in a bank that pays 8% converted semi-annually. Find the future value and the interest accumulated at the beginning of the period. In this example, we have R equal 750 and it will be paid for each 6 months and for 5 years. So the total time here equal 5 years, and we have 10 annuities. In a bank that pays 8% converted semi-annually, so J equal 8%, M equal 2, and I will be equal 4%. Note that the annuity each 6 months and the interest will be accumulated every 6 months. We have 8% converted semi-annually. So the required here, find the future value and the interest accumulated at the beginning of the period. For R equal 750 and T equal 5 years, and for J equal 8% and M equal 2, so I equal 4% and N will be equal 10. S double dot sub N equal R times 1 plus I to the power of M minus 1 over I times 1 plus I. We have S double dot N equal 9,364.76. To get the interest, we have B, the principal. B here equal R times N. R 750 times 10, we have $7,500. And where is S double dot N equal 9,364, so the interest will be equal 1,864.76. Exercise number 3. A man deposits $1,200 at the beginning of each month for 2 years in a bank that pays 6% compound monthly. What's the future value and the interest accumulated at the beginning of the period? In this example, we have R equal $1,200. At the beginning, it means the annuity is due each month for 2 years. So the total time equal 2 years and the annuity each month. We have N equal 2 times 12, so N equal 24 annuity. In a bank that pays 6% compounded monthly, J equals 6%, M equal 12, so I equal 6% over 12. The required. What's the future value and the interest accumulated at the beginning of the period? In this example, R equal 1,200, T equal 2 years, J equal 6%, M equal 12, and I equal 5%. We have I from the formula, I equal G over M, and N equal 2 years times 12 equal 24 annuity. In a formula, S double dot N equal R times 1 plus I to the power of N minus 1 over I times 1 plus I. We have S double dot N equal 30,670.94 dollars, of course. In this example, to calculate the interest accumulated, we have S double dot N minus N times R. We have S double dot N 30,670 minus 1,200 times 24. Another example. Suppose after retiring in 25 years, a person plans to have $100,000 in his account. If the bank pays 5% compounded monthly, how much does he need to deposit in his saving account at the beginning of each month to achieve his retirement goal? In this example, he gave you $100,000 as a future value and you need to calculate R. The total time equal 25 years and J equal 5%, M equal 12, so I equal 5% over 12. With that, the annuity here will be each month. So to calculate N equal 12, which is equal M, times the total T, 25 years. So we don't have R is unknown, and S double dot N equal 100,000, T equal 25, J equal 5%, M equal 12, so I equal 5 over 12, N equal 300. We will substituting for S double dot N with $100,000 and for I with 5% over 12 and for N equal 300. So we get R equal 167.23. If he asked for the interest, in this example, we will use the formula of the total interest, equal is double dot n $100,000 minus n times r, n with $300 with 300 annuity times $167.23. Another example, exercise number 6. A person has paid $300 at the beginning of each 3 months on his home mortgage loan. Because of coronavirus, he asked his lender to suspend the payment due on January 1, April 1, and July 1 to be paid the payment of October 1. If the interest rate on the mortgage is 10% compounded quarterly, how much should he pay in this date, and how much of interest he did pay? In this example, we have annuity in January 1, April 1, and July 1. And we need to pay this annuity with the annuity of October 1. So we have 4 annuities. To solve this problem with annuity due, we will consider that the payment of January 1 and April 1 and July 1 will be paid on October 1. Then we will add the payment of October 1 to the result from the previous step. We have R equals 300, J equal 10%, M equal 4. Note that we have 4 annuity, N equal 4. To solve this problem with a formula of due annuities, we will substitute for N with 3, not 4. Then we will add the last annuity to the result. Also, you can solve this problem with the formula of ordinary annuity, and you will get the same result if you substitute for N with 4. In this problem, we will use annuity due formula is double dot n equal r times 1 plus I to the power of n minus 1 over I times 1 plus I. So S double dot n will be equal 1245 after we add 300 to the result of S double dot n. The interest accumulated equal 1245 minus R times n. R equals 300 times 4. Another exercise number 8. On March 1, a person bought a car from a car dealer for $5,000 down payment and $200 at the beginning of each month for 3 years. The buyer made the March and April payment March and April payments and asks the dealer to postpone the receipt of the payment until November 30. If money is worth 11% compounded monthly, how much should he pay to settle all the obligations? Note that we have R equal to 100, J equal 11, J equal 11%, M equal 12. So we have I equal 11 over 12%, and we have N equal 7. Look at the exercise. The buyer made the March and the April payment and asked the dealer to postpone the receipt of payment. Note that we have uh, we have annuity each month for 3 years. So if he paid the March and the April, then we have May, June, July, August, September, October, November. We have 7 payments. We have 7 annuities. All these annuities will be paid on November 30. So N equals 7. In a formula of annuity due S double dot N equal R times 1 plus I to power M minus 1 over I times 1 plus I, we have S double dot N equal 1452. Exercise number 9. Payment of $1,000 each are made at the beginning of each year for 5 years. What is the present value of these payments if interest rate 8% compounded annually? In this exercise, he asked for the present value. The formula for the present value, A double dot N equal R times 1 minus 1 plus I to the power of negative N over I times 1 plus I. We have R equal $1,000, and for T equal 5 years, J equal 8%, M equal 1. So I equal J equal 8%, and we have 5 annuities. We have 5 annuities. A double dot N will be equal 4,312. Another exercise number 11. An annuity due of $750 each 6 months for 5 years in a bank that pays 12% converted semi-annually. Find the present value. We have R equals 750, and for T equal 5 years, J equal 12%, M equal 2, I equal 12% over 2, we have I equal 6%, and for N equal 10, then in a formula of A double dot N equal R times 1 minus 1 plus I to the power of negative N over I times 1 plus I, we have R 750 times 1 minus 1 plus 6% over to the power of negative 10 over 6% times 1.06. We have A double dot M equal 5,851.3. Exercise number 12. A man deposits $1,200 at the beginning of each month for 2 years in a bank that pays 8.5% compounded monthly. What is the present value of these payments? Also, he asked for the present value. In this problem, we have R equal $1,200 and this payment or this annuity will be paid at the beginning of each month for 2 years. So we have the total time equal 2 years and the number of payments, the number of annuities equal 2 times 12 equal 24 payments. In a bank that pays 8.5% compounded monthly, then J equal 8.5%, M equal 12, and I equal J over M, 8.5% over 12. By substituting in a formula of A double dot of M equal R times 1 minus 1 plus I to the power of negative N over I times 1 plus I, then A double dot N equal 26,586.34. If he asked for the interest, in this case, we have R equal 1,200 and N equal 24. $1,200 times 24 minus 26,586. Thank you for watching. For any question, leave your comment at the bottom of the video and I'll try to answer it next time.